Okay, we are recording. You get time and Rick, or Sione?
Yep.
Okay, tear it up. Team
Okay,
one.
well, my name is Ricky Tofita. Thanks for coming to this. So first off, this is basically our Kaizen event. So the problem statement states, from May to July of 2013, Smith Factories had 108 four center non-conforming returns from AMP, the standard is 0. So our link to this strategy was basically responsiveness with the NCR sent to us. So these next couple graphs just kind of give us an idea. So as we talk about the rejects sent to them, this is just a little bit of a breakdown to it. So we look at this graph on the right, it's a little hard to see right now. So this actually says poor center, says chip, COSD, and CRK, so our cracks. We noticed just in those 3 months time frame that poor center by far had the most amount of rejects within that time frame. Just to kind of give a graph scale, this is what it looked like if you paraded it by month. So we saw a huge peak. For those of you who are unfamiliar with seeing a poor center, this is kind of a visual image of it. This little depit, or these little void marks, are what we call poor centers here. So if you can scroll down. Yep, I'm done. So first thing is we want to understand is just basically where this actually happens. So in the press is where it actually is made due with the heat and time and pressure. But the actual first place to actually detect these for us at US Synthetic is actually at our lapping station. Who it's affected mostly is between the two Smith Value Stream teams, and that's Montana and Sonoma. And it happens across the board. It's pretty much all of our parts. So as we look at this, our goal was basically by October of 2013, we will reduce voice sent to the customer by 10 or less per month. And that's where we're at right now. Want me to keep going?
So are you done, or?
Well, we have more, but it's not formatted.
Okay.
So if you want me to ramble on it.
No,
No.
I mean,
If
whatever
this is-
you're prepared to do,
Yep.
That's what we're
let's evaluate that.
So just to get that clear evaluation, it was 2 minutes and 52 seconds on just that part right there.
So that's too long.
That's way too
2:52 long. Okay.
Would it be beneficial to offer feedback now?
Let's do it again.
Okay, so let's
Go bam, bam, bam.
let's offer any feedback we have right now as a group. Any observations you made, anything that Ricky and Sal could use to their advantage here.
It's on already for myself.
Yeah.
Graphs are hard to see, to read. Numbers letters are pretty small.
There's no link to strategy. I actually said that.
You
There's
said
no
that after
link.
the problem statement, not at the beginning. So it's not really right here. We might be able to put that.
On target.
That's what I have.
Who's AMP?
Where did you get it? Oh yeah.
So, I don't know who AMP is for that. Are they a customer, are they
Acronyms,
Yeah.
careful of acronyms, spell them out.
or you can just say returns from
Customer. Okay.
I mean, that's kind of given, but when you read that,
Yeah, that's true.
I was also confused from May to July 2013. But
Yeah.
Maybe that was just me.
So we talk about problem statements specific. Are you talking May 1st or May 30th?
Just the
May,
month.
July, the whole month.
Yeah.
So again, when we just look at that though, we don't know. There's a question in our mind to be able to say, when you say the whole month, does that mean the whole
No,
month, or is that?
Well, we generally, when you refer
First.
to months, you're usually referring to a longer date span, like May of 2013 to July of 2014. But when you say from May to June, it was May to July, it was such a short time frame that I stumbled on, are they talking about the same year?
Okay.
Anyways, if you're talking that big
That's why I would-
a time, you generally would have a date, because you're only talking 3 months or 2 months.
Those are some
3 months.
circles.
Gotcha.
Same similar thing for PS, Port Center. We know what PS is, but nobody at Dover is gonna know what PS is. So any acronym, at least make sure you use parentheses behind them and say what it means.
The other thing is, you use the term void. If it were me, I'd call it void. That's what our customer calls it, and when you were describing what
That's
it
not
is-
what we call, yeah, it's,
I know that, but when you were describing.
We kinda
it,
went
You said,
opposite
see these
route.
voids right here? So,
So consistent words with whatever you're choosing to describe it.
yeah, you can say, see this, these are Port Center right here, but you end up saying, see this, these voids.
Let's see. Okay, we've covered everything I had. I would add one thing that you should know this material good enough that you don't have to read it off those boards at all. Who's giving the presentation, Sal, you or Ricky?
You can have note cards though.
You have no cards, but what you don't want to do is be turning away from your people who are watching you
Audience.
to read what's on the charts. If you're doing that in any that's like presentation 101. You don't ever want to do that. You want to know that material inside and out so you can just literally talk to your audience and
Look at the
occasionally
point and.
refer, do some sort of motion here, but kind of just presentation.
Yeah, what it says when you look there is that you don't know your material. That's what that's saying.
and I didn't.
So.
Well,
All right,
see,
use a
the-
practice,
yes,
yeah.
that's why we're here. The rule holds true.
Yep.
So, yeah, and so, what I hope you guys all learned was that was really advantageous to do that. Ricky, you may have been a little uncomfortable, but I assure you it's more comfortable here than up there
No, I'm sure.
in front of the executive team and the grading committee and they're throwing hardballs at you and questions and.
I don't think there's anything wrong with reading your problem statement or your goal statement though, because it makes sure you get it right.
And make it big and clear. All right, so, anything else? Dennis? Any feedback?
I'm learning a lot from you always, so I'm learning just as much as these kids are.
Fair enough.
I'm happy to be here.
All right, who's presenting out of Team Dos?
I am,
Come on.
unfortunately.
They're team one, we're team A.
There's Jake
You're
McClellan.
freaking Awesome.
Let me ask you this, do any of you need 5 minutes or 10 minutes to alter anything on your presentation based on that last feedback stream? Would you like,
Yeah.
Yes.
or should we, I mean, because we could take 5 minutes or 10 minutes and quickly beat it up right now. I mean, I'm looking around to see, I think the investment is worth it, but I know everybody's on time constraints too, so which way do we do this?
I think that I would like to adjust it later.
Yeah, just roll with it,
Okay.
because there might be more adjustments later.
Yeah, so what we found out in past is that if you present one like this, you go back and make changes, then you need to go and present it again.
Okay.
So the idea behind this is you're gonna practice it a lot of times.
Tomorrow.
I mean, a lot of times. You may think, okay, that's pretty good, and then practice it more. That makes a great presentation when you practice it a lot of times. With feedback though.
With feedback.
Not just looking in the mirror and saying it because then it could be totally wrong. You gotta have an audience that can critique you.
Okay, timer man, hit us up with another 5.
Okay, whatever.
Okay. My name's Jake McClellan. Problem statement was that on 110, my chronometer was drifting 2 thousandths out of calibration on 3 separate occasions, causing large diameter rejects to be passed on the value stream. Basically what we did, so the mic was exposed to coolant, vibration, and possible magnetic fields. We were using bad setup pins. We were using setup pins to calibrate the micrometer, which is, they could have flat spots or anything like that. And then the standards for calibration weren't being followed like rigorously. And so our goal statement, by Monday, 1/13/14, we will eliminate the cause of drifting micrometers and send 0 large diameter rejects downstream. So our fishbone, we did the man, material, method, machine. And we found out the CG pins were being used to carbon micrometers, and the glue bar vibrates the micrometer. Hypothesis, if we take the micrometer off the top of the glue bar, then it will stop drifting because it will no longer be subjected to coolant, vibration, and whatever magnetic fields are present. If we create a system to make sure that only certified calibration pins are used, then we will not have bad calibration. So one thing, a root cause and countermeasure, we took the micrometer off the machine and affixed it to a table that doesn't move, has nothing hooked up to it. And that was our big win on that. And then another thing we did was we got some certified calibration pins and affixed them to the micrometer stands. So they're always there. Never have to look for them. We met our goal in the PDCA on 1/16/2014 when we installed the mounting arm for the micrometer, stopped having problems with the micrometer drifting, and sent 0 LDIA rejects downstream. And we're currently in the process of working with Rocky and Chris to yoke down the calibration pin poke yoke that we made. And these improvements were made by the hard work and dedication of the Fontana team.
What's the time?
So that took you 2 minutes and.
You're counting down?
It's counting down.
So you're 3 minutes and 40
seconds,
seconds.
yeah. You have 2 minutes left. 19 seconds, so under the 5 minutes, like you still got a couple minutes.
Yeah, I'd hone these down to where you finish like 5 seconds before otherwise you're leaving available time to tell that story. As long as it's clear, you don't want to make enough stuff around when you want to use that whole time frame for clarity. All right, feedback?
Go back to the beginning.
Yeah.
Can you do it as a slideshow, Sal? So it'll show the slide.
That's the thing.
Okay. So, one of the things is in your understanding the problem that I see is you have some problems in there that the pins were getting dirty. You don't mention anything about not using uncalibrated pins, but that was your solution.
So we mentioned it here in CG setup pins, because the CG setup pin is not the same. So maybe we need to clarify better.
Okay. And you mentioned when you were talking that they were getting dirty. Is that true, or did I make that up?
They're getting dirty and flat spots on them.
Okay.
People use them as a setup pin.
Okay, so those were understanding of, but I didn't see any of that in actions. And I would think that's more along the lines of root cause analysis. What I see here.
Okay.
That looks to me like root cause analysis as opposed to just understanding the circumstance. I like the first one. The first one says, hey, this is how we do it. But I felt when you were talking about it, you were really highlighting root cause analysis stuff.
So your problem statement, I'm not really clear on. And when I say clear, this is what creates a good problem statement? What's
Clear,
your
concise.
clear, concise,
Measurable.
measurable, standard deviation? So is, I see a standard. I see a deviation there. Saying your
There's
micrometer
actually-
glue bar drifted 0.2 on 3 separate occasions. Is it only supposed to drift 0.001 or 0, or it's not, you're not clear on your problem statement? Because then it's saying, well, it's caused by something, it's causing this. That's the effect, but it's not.
I think the causing LDIA's rejects.
Should that be in the understanding
That should be a
circumstances?
problem statement. The drifting micrometer. Because at the beginning you didn't know why, right?
I just wasn't
No,
clear on
we didn't.
really what your
Yeah,
problem.
the problem is you're setting out LDIA.
That was your problem. You didn't know why, right? Then later on you find out that you have drifting micrometers, right? That was one of the things that you were able to find out by
Yeah.
grasping the correct.
During your root cause analysis,
Yeah.
right? So I see you got LDIA, and if I wasn't a diamond guy, I would have no idea what LDIA is. We talked about that.
Yeah, I've got it all circled on my paper.
So, in your root cause analysis, I agree with Jeff. You're doing root cause analysis, you're saying the mic is exposed to coolant and possible magnetic fields. So the magnetic field part, I guess what you're saying is the measuring instrument is being exposed to environmental conditions, perhaps at the manufacturer, that the device is not intended to operate in that environment, right? As far as thinking that there might be magnetic fields, rather than throw that out there, if we knew the device negatively reacted to magnetic fields, and we could show there was a magnetic field there, that would be one thing. But if we're saying they
It's
could
just a
be there,
guess.
they could be there, they may not be there, we don't even know if it has an impact on the device, I'm not sure I would throw that out there.
Okay.
For speculation. But if you're doing root cause analysis, basically, in a nutshell, you're saying, look, our calibration device is exposed to an environment that the manufacturer either says don't expose it to, or that we've learned is bad. So how do you tell that a little bit differently?
So what I would do though, as far as that goes, at this point, if I'm an outside from US Aesthetic guy, I don't even know what process you're doing.
Right.
So I would answer the questions of who, what, when, where, how. I would be answering, we do a CG process, we do this is the machine, you know, I don't even know what process you're doing, let alone, you know, if I'm an outside US Synthetic guy. So I would understand the circumstance to describe, we grind a part, we measure a part, if it's good, we pass it on, if it's bad, we reject it. Something, you know, just tell about the process.
So let me ask you this question. When this problem occurred, did you guys actually go through and go through the PDCA cycle, as in, this is our problem, this is how we understand your circumstances? Did you create a problem statement before you came with the solution?
We did some understanding and root cause analysis before we did, because it was an inflow right now type of problem. But that day we started with the problem statement and understanding the circumstances, and worked together as a team to develop that understanding further later.
Okay.
So I don't know. I tried to use it as a teaching method to walk them through the PDCA process, because it was a good example. It was a good quick fix type example that we could use. So
So just hearing that whole story, to me, when I looked at that, what that told me was that just seeing that, it looked like the process went really fast, and you came to the cause and you fixed it really fast, but you really didn't follow the method. And that's what this just felt to me when I went through it. So that's why I just asked the question, because you can see, once you've done PDCA enough, you can start seeing if people really follow the method, or if they just said, well, we fixed this problem and we're going to kind of go back and kind of fill in some of the blanks. And that's what this kind of feels like to me. But you said you
And the judges will be, having judged a lot of this, that's been a case in a lot of them that they've reviewed, so they'll absolutely be
especially here.
tuned in on that.
Here, you'll see, they'll see that, you know, you get Eric or Rob looking at that, and they'll see that really quick. So
Your visual on your finished diameter was 531. I have no idea
we didn't say what target was or
what it ought to be, right? In fact, based on what Jake, you know, the part of the process where you didn't describe what I was doing, I don't even know what that is. You're assuming I know that that's a PDC cutter that's got diamond on it and that it's supposed to have some diameter of something, right? I mean, there's a lot of assumptions built in that.
Mhm.
And I think if you're in this group, you understand that. But outside of this group, you know, finished diameter was this. All right. I'm not sure what that tells me. LDIA rejects were passed on. I don't know what LDIA is, and I don't know what PC is.